Okay, good morning, everybody. Praise be to the Lord.
Now and
Now
forever.
and
Forever.
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 Now and forever.
Okay, guys, we're going to continue with math, and we're going to continue with the measurement of length. We're going to continue with the topic because it's really extensive, right? And we're going to see the measurement metric units of length. That will be the topic for this hour. In the next hour, we're going to make some exercises from the book, okay, from the pages of the book, to continue with that topic. Okay, so please, right now, let's pay attention, okay, because I will show you a video, and then I will show how can I say a PowerPoint presentation about that. So let's see.
Monster Math presents Addition Below 10. Okay, class, let's begin. What is 5 plus 3? We can solve the problem by count.
Hi, this is Rob. Welcome to Math Antics. In this video, we're going to introduce the concept of measurement, which is an important topic in math, and especially in science. We're also going to take a look at a particular system of measurement called the metric system. Objects have different physical properties, right? Like size, weight, volume, etc. Well, the whole point of measurement is to quantify those properties, which just means expressing them as a number. Without measuring, you could say that someone is tall or short, or that a package is heavy or light. But those are relative terms that don't give us very specific information. Instead, if you were to make actual measurements, you could say that someone's height is 130 centimeters, or that a package weighs 5.2 kilograms. Measurements use an actual number to describe properties like that, so that you can know them more precisely. But there's a catch. Unless you know what a centimeter or a kilogram is, those measurements won't be very helpful. Centimeters and kilograms are examples of what we call units of measurement. Units of measurement are predetermined quantities that we use as references, and it's really important to be familiar with common units of measurement so you know what various measurements mean. Units of measurement aren't something fundamental to math like addition and subtraction are. Instead, they're amounts that people invent and agree on so that we can communicate. In fact, we could agree to use just about anything as a unit of measurement. I could tell you that I'm 13 hot dogs tall, and my weight is 3,259 donuts. The problem with those units is that hot dogs and donuts aren't very consistent, and unless you and I are using exactly the same hot dogs and donuts to measure, we'll probably come up with different results. To get around this problem, the units that we use in math and science are standardized, which means that they match official standard amounts that can be measured over and over again to give exactly the same result. There's even a government agency called the Bureau of Weights and Measures that defines and maintains those standard amounts. Well, what do we have here? Nothing, just measuring stuff. Let me see that. Ha! Just as I suspected, this isn't properly calibrated. I just had it checked. Yep, gonna have to take it into the lab for adjustments. Don't let it happen again. So, is there a number I call to get that back? Of course, getting a bunch of different people to all agree to use the same standards is not always an easy task. And throughout history, a variety of different units have come in and out of popularity. For example, the ancient Egyptians used units like cubits and kites, which aren't so popular today. In modern times, there are still a lot of different units used in different countries, but the most popular system of units used around the world is called the metric system. Well, its official name is the International System of Units, or SI units for short, which stands for the French System International, but the term metric system is still often used to refer to this system. The metric system is a really great idea because it makes the math involved with certain measurements and unit conversion much easier to do. That's because just like our base 10 number system, most units in the metric system take advantage of powers of 10. The idea behind the metric system is to start with a base unit and then use standard prefixes to make other units that are bigger or smaller than that base unit by powers of 10. Here's a list of some of those prefixes. To see how they work, let's consider a key unit in the metric system called a meter. A meter is a basic unit of distance or length, and it happens to be about this long. As you can see from our prefixes, the unit that's 10 times bigger than a meter is called a decameter. The unit that's 100 times bigger than a meter is called a hectometer. And the unit that's 1,000 times bigger than a meter is called a kilometer or a kilometer. But this system also has prefixes to define units that are smaller than a meter. The unit that's 10 times smaller, or 1/10 of a meter, is called a decimeter. The unit that's 100 times smaller, or 1/100th of a meter, is called a centimeter. And the unit that's 1,000 times smaller, or 1,000th of a meter, is called a millimeter. Get the idea? There are also abbreviations for each of these units to make writing them down a lot more convenient. A meter is just abbreviated as M, and then you put other letters in front of that for the other units. For example, a kilometer is abbreviated KM, while a centimeter is abbreviated CM. So why does the metric system make working with units easier? Well, notice the pattern we get if we put these units in order with the largest unit on the left and the smallest unit on the right. Each unit is 10 times bigger than the unit immediately on its right and 10 times smaller than the unit immediately on its left. That's exactly the same pattern that the number places use in our decimal number system. This diagram can give you an idea of how the units relate to each other. For example, 1 kilometer is the same as 1,000 meters, and 1 millimeter is the same as 0.001 meters, or 1/1000th of a meter. And because all these different units of length are based on powers of 10, you can convert between them just by shifting the decimal point one place at a time, which is equivalent to either multiplying or dividing by 10, depending on which direction you shift. 2.754 kilometers is the same as 27.54 hectometers, which is the same as 275.4 decameters, which is the same as 2,754 meters, which is the same as 27,540 decimeters, and so on. You can convert to the next smaller metric unit by shifting the decimal point to the right, which is equivalent to multiplying by 10. And you can convert to the next bigger metric unit by shifting the decimal point to the left, which is equivalent to dividing by 10. For example, 9.8 millimeters is the same as 0.98 centimeters, which is the same as 0.098 decimeters, which is the same as 0.0098 meters, and so on. So you can see why the metric system is so useful. It was designed with our number system in mind, which makes it easy to work with. Oh, and even though the metric system defines a lot of different units with all these prefixes, not all are equally popular. For example, it's not very common for people to use decameters. They'll usually just say 10 meters or 25 meters instead of saying 1 decameter or 2.5 decameters. In fact, there's really just 4 metric units of length that are frequently used, and they are the millimeter, the centimeter, the meter, and the kilometer. Oh, and of course, nanometers are commonly used when referring to teeny tiny stuff like microbes or computer chips. A nanometer is 1/1 billionth of a meter. So that's how metric units of distance or length work. But there's another important quantity that uses this same powers of 10 prefix pattern, and that's mass, or weight. Mass is a measure of how much actual matter an object contains, which is closely related to its weight on Earth. In the metric system, the basic unit of mass, or weight, is technically the kilogram. But we're going to start with just the plain old gram to see how the same prefix pattern we use for length can be used for mass also. For reference, a gram is the amount of mass equivalent to 1 cubic centimeter of water. A decagram is 10 times bigger than a gram. A hectogram is 100 times bigger, and a kilogram is 1,000 times bigger. And similarly, a decigram is 10 times smaller, or 1/10 of a gram. A centigram is 100 times smaller, or 1/100th of a gram. And a milligram is 1,000 times smaller, or 1/1000th of a gram. See, the same pattern is used. And all of these units of mass have abbreviations also. The pattern of abbreviation is similar to the metric units of length, but instead of an M for meters, you use a G for grams. kg is kilograms, mg is milligrams, and so on. Again, because these units of mass are based on powers of 10, you can convert between them just by shifting the decimal point. You can convert to the next smaller metric unit by shifting the decimal point to the right, which is equivalent to multiplying by 10. 5.24 kilograms is the same as 52.4 hectograms, which is the same as 524 decagrams, which is the same as 5,240 grams, and so on. And you can convert to the next bigger metric unit by shifting the decimal point to the left, which is equivalent to dividing by 10. 16.3 milligrams is the same as 1.63 centigrams, which is the same as 0.163 decigrams, which is the same as 0.0163 grams, and so on. But, as was the case with units of length, many of these units of mass are not used as often as the others. For example, centigrams aren't as popular because people will usually just say 10 milligrams or 25 milligrams instead of 1 centigram or 2.5 centigrams. The units of mass that you'll most commonly encounter in everyday life are the milligram, the gram, and the kilogram. So make sure you're familiar with those. All right, so that's the basic idea behind measurement and the metric system. Measurement helps us describe things in the world we live in and to compare them using units. And the units in the metric system are specially designed to play well with our base 10 number system. But it's important to know that the SI or metric system does use some units that are not based on powers of 10, like time, for example. The basic SI unit of time is the second. But units of time that are larger than a second are still the traditional ones that are based on the motion of the Earth and the Sun, like minutes, hours, days, and years. Fortunately, units of time that are smaller than a second do use the base 10 prefixes, such as milliseconds and nanoseconds. I wish I had more time to talk about time in this video, and all the non-metric units that are still commonly used today, like feet or pounds, but I'm afraid those will have to wait for future videos. There aren't too many exercises for this lesson, but if measurement and the metric system are new topics for you, you might want to give them a try. As always, thanks for watching Mathantics, and I'll see you next time. Learn more at mathantics.com.
Okay, guys, if you see the video, it's really specific about mathematics. This guy is really, it's really good to explain a little bit about this kind of topics. If you see, we have a many unit, or how can I say it? We have many measurement metric units of length, right? If you remember, we have distance. We have also, actually in distance, we have kilometer, meter, hectometer, right? I think you already didn't know about that exist, the hectometer. And also we have in grams. The only thing is the thing you're going to measure, right? We have kilometers to measure distance, okay? And we have grams, and that is a measure you're going to weigh, to measure the weight or something, right? So let's see. Everybody can see the screen, yes. We have measurement metric units of length, right? Sorry. Okay. What will you use, or what will you use to measure a metric unit? Let's go to discuss this. Discuss which item you will use to measure each object. There may be more than one suitable item. For example, we use meter stick. trundle wheel, ruler, pedometer, small tape measure, large tape measure, right? What do you use? We actually using common rulers, actually. All of us in the classroom, in your homeworks, the most thing you use is homework. Sorry, it's a ruler. For example, what are you going to use to measure a crab?
Ruler.
A ruler or a metal stick, maybe also. A small tape measure could be also. You're going to use to measure a crab. What do you choose to measure a crab?
Ruler. Ruler.
A ruler. Me gusta la emoción con la que están. ¿Qué venga?
Ruler.
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 A ruler. Esa emoción es la que me llena a mí totalmente. ¿Qué van a hacer? Nada. ¿Ya comieron? Sí. ¿Están despiertos? Sí. Me llega esa emoción de ustedes, ¿eh? Y son plenas 8, van a ser las 9 de la mañana apenas. Páñense, hombre, para que les quite el sueño. A la realidad. Con agüita caliente no. Agua helada para que les quite el sueño. Aha, let's continue. You're going to use a ruler, right? To measure a crab. What are you going to use if you're going to measure a length of pier?
Large tape measure. Large tape measure. Large tape measure.
Could be a large tape of measure.
Pedometer.
A pedometer.
Oh.
Pedometer, I don't know what is a pedometer. Pedometer measure your heart, the way you breathe.
La presión.
Exactly, the pressure of your body, right? That is a pedometer. Could be a large tape of measure, a large tape measure, or a trundle wheel. Could be also. Let's see other one. Length of coach. What are you going to do?
Large tape. Large tape. Large tape measure.
Could be the both,
Large
the
tape
small
measure.
one and the large one. Could be the small tape measure and the large tape measure. Could be both. Right? So, I don't know. Could be both. Let's see. Length of a kite string.
Meter stick. Tape measure.
Huh?
Meter stick. Meter stick.
A meter stick could be. Could be a meter stick, a ruler, or small tape measure to measure a kite. Length of a beach towel.
Meter stick. Small tape measure.
Could be a meter stick or a small tape measure, right? And the length of a beach, what are you going to use?
Trundle wheel. Tape measure. Trundle wheel.
Could be a trundle wheel or a large tape measure also, right? But in this one is almost what? Maybe 500 meters, maybe. And the trundle wheel, sorry, is going to continue, right? Length of an ice cream cone.
Ruler.
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 Yeah, it could be a ruler. It could be a ruler. Now, Well, actually, we know we already discussed. For example, let's see. What other seaside items you could measure with the different items? So, for example, what other things you can measure with a ruler?
A page.
Okay. Ah, a page. Yes, a page. What
A
else?
notebook.
A notebook. What else?
A cup.
A cup. A what?
A book. A pencil. A book.
A pencil.
A car. Yes. A book, a
A
notebook.
car.
A cup of coffee.
And you sleep with a cup of coffee. Somebody said a cup, so you can say another one.
A bag of coffee.
Sí, Roland. Okay, it could be a pencil, a cell phone, my earphones, my glasses, my watch, using a ruler. Now, what can you measure with a pedometer?
Heart pressure.
Not the heart pressure, actually. A pedometer can measure the heartbeat. How many heartbeats you have in a minute? O sea, latidos del corazón. How many heartbeats do you have in your heart? How many steps you make in one day? For example, also in the cell phones we can have pedometers. For example, let's see if I have it in here. This one.
Samsung Health.
No. For example, this one that says LG Health. That one. That one is used to measure how many steps I made in one day. Actually, in these days I can use it because I don't walk a lot. I didn't even go out to my house, staying home. It measured how many steps you made, how many heartbeats you have in one day or in a minute or in an hour. Measure also what else? Measure also the distance you take, okay? Maybe walking, maybe running, maybe driving also. That is a pedometer. The pedometer measure everything actually, right? So let's continue. Now, what I will use? Now, you have chosen the measuring item. Which unit do you think would be the most suitable for measuring a thing? Okay, we have centimeter, millimeter, meter, and kilometer, right? The only one that doesn't appear here is hectometer, right? That is the only one. But why? Because it's not really common to use it. But these ones in here are really common. A crab, where are you going to use it?
Centimeters.
Centimeter. No sé, chicos, que se les quede la pronunciación, porque muchas veces dicen centimeter, centimeter, kilometer, kilometer, or kilometer, if you want to pronounce stronger. Okay, a crab, it's centimeter. Length of pier.
Kilometer. Kilometer.
Could be kilometer, could be meter, could be both. Because some length of period can measure only meters. Some of them measure kilometers, actually. Length of coach.
Meter.
Meters.
Meter.
Meters. Length of a kite string.
Centimeter.
Remember, a kite string is not all the kite. The only thing is this one, the kite string.
Centimeter.
Could be centimeters, maybe a meter, but the most common is centimeters. Length of a beach towel.
Meter. Centímetro.
Una toalla puede medir metros.
No.
Centímetro.
Porque ese que dijo metro. Digo yo, o sea, que va, pero es palancón el hombre. No, hombre, no. Es gigantón, le van a decir de cariño. Ok, length of a beach.
Kilómetros.
Kilometers. Actually, are some beaches that only have meters. For example, somebody have been in Amapala.
Yes.
There is a beach that is called Playa Blanca, I think, or Playa Negra. Playa Negra. And that beach is actually small, actually. Not like the beach of the beaches of Tela, the beaches of La Ceiba. Those ones are really big ones. Even the beach of in the south, the beach of Cedeño, it's big one, really big one. But Playa Negra is small one, really small. Maybe meters you can measure in there. And do you know why we call Playa Negra in there?
Porque la arena.
The sand is negra.
The sun is negra, Dios mío.
Porque hay volcanes.
No.
Porque la playa. Porque es una.
Because the
Yes, but I want to
because
hear
el
I
mar
want
es
to hear you
negro.
in English, not in Spanish, people. The class of Spanish is with Miss Jessica, not with me.
It is a volcanic beach.
Because
No.
the sea is
Because the sea is black. No.
Because the sun is black.
Exactly, because the sun is black. But do you know why the sun is black?
No.
Oh,
No.
okay.
It's by a volcano.
Because it's volcanic land. No, pero que me estaban diciendo, ay, es porque ahí hay volcanes. Pucha, pero Amapala no es un volcán. O que cerca de Amapala hay un volcán. No. Okay. Use multiplication to convert between units of length. Right? There are 1,000 meters. We already know that. There are 1,000 meters in a kilometer. So we need to multiply by 1,000 to convert from kilometers to meters, actually. Also, there are 100 centimeters in a meter. So we need to multiply by 100 to convert from meters to centimeters. And there are 10 millimeters in a centimeter, so we need to multiply by 10 to convert from centimeters to millimeters. We already know that, right? Since we start to talk about the measurement units, we see this, we saw this. We know that, actually. This chart helps us to visualize how to convert a larger unit of length to smaller unit. Kilometer to meter, you have to multiply by 1,000. To meter to centimeter, I hope you copy. You're going to multiply 100. Centimeter to millimeter, you're going to multiply by 10. If you don't finish the copy, don't worry. The videos will upload on YouTube because we don't have much time and I have to continue. Now, using division to convert between units of length. There are 1,000 meters in a kilometer. So we need to divide by 1,000 to convert from meters to kilometers. There are 100 centimeters in a meter. So we need to divide by 100 to convert from centimeters to meters. And there are 10 millimeters in a centimeter. So we need to divide by 10 to convert from millimeters to centimeters. Now, how we can use it this? Also, I have a chart in here. From millimeters to centimeters, I have to divide it by 10. From centimeters to meters, I have to divide it by 100. And from meters to kilometers, I have to divide it by 1,000. If we put that chart together, it will help us to convert between larger to smaller units and vice versa, right? In this way. So let's continue. Let's see to practice your conversion skills to convert these measurements. Use the conversion charts to help. The first conversion the first conversion has been done for you. I don't know what is the first conversion. The first one, 4,700 kilometers. How many meters is this one? You have to multiply by 1,000. How many?
4,735.
Exactly, 4,735 meters. Remember to finish all the phrase. Si no me dices si son peras, manzanas, sandías, metros, minutos, segundos, kilómetros o centímetros, está malo. Me tiene que decir exactamente qué es. Okay? The second one. Oops. We have 8.63 meters. Let's try to convert it in centimeters. How many is it?
863 centimeters.
863 centimeters. Follow the chart we have below. I have 5.8 centimeters. And I have to transform it to millimeters. 58 millimeters. Let's see the other one. Let's see the other one. I have 2,500 meters and I have to change it to kilometers. So what I have to do in here? Divide.
2.5.
2.5 what? Kilometers. I have 385 centimeters and I have to change it to meters. So I divide it by 100. That's it.
3.35 meters.
35. 38.5 meters. And the last one, 97 millimeters to centimeters, it's only 9.7 centimeters. We could combine the charts to create his single chart, okay? As appear in this way. We have kilometers, meters, centimeters, millimeters. From kilometers to meters, multiply, okay? And on. From millimeters to centimeters and on, you have to divide. This will help you to convert units which are not next to one another. You can copy your notebook when the video is finished, okay? What calculation will you do to convert from meters to millimeters? For example, if you have meters, but you need 2 millimeters, what conversion are you going to use?
Multiplication.
Yes, but how many? First of all, you have to make it by 100 and then by a 10, right? So from meters to millimeters, you have to multiply by 1,000 because exists 1,000 millimeters in 1 meter. Okay? kilometers to centimeters. How many? The same way. From kilometers to meters, we have 1,000. And from millimeters to centimeters, we have 100. So from kilometers to centimeters, you're going to multiply by 100,000, right? To find how many centimeters we have in 1 kilometer. So from millimeters to meters, the same way. From millimeters to meters, we have 1,000, right? It's the same way, only with division, actually. From convert to centimeters to kilometers, you have to know each meter is 100 centimeters, and each kilometer, sorry, is 1,000 meters. So you have to divide by 100,000 centimeters, sorry. So let's continue this quickly. So we have 4 meters in millimeters. We have multiplied by 1,000, we have 4,000 millimeters. From the second one is 0.875 meters. 5 kilometers to centimeter, we have 500,000 centimeters. The next one is 80,000 centimeters, we have 0.89 kilometers. And 825 millimeters, we have 0.825 millimeters. We have in here some questions, okay? And we're